So for the second example, this is a kind of bridge between the AS and your A2 calculus really. So let's take a look at this one. A small metal ball moving in a magnetic field is modelled as a particle P of mass 0.2 kilograms, moving in a straight line under the action of a single variable force F newtons. At time t seconds, the displacement x meters is given by x equals 3 sine 2t. Find the magnitude of F when t equals pi by 6. So in order to link motion and force, then we'll be using Newton's second law. So by N2L, Newton's second law, F equals ma, and we're going to get from displacement to acceleration by differentiating twice. So first of all, we'll get v equals dx dt. Now what we have here is an embedded function, so you need to use the chain rule in order to differentiate that, and you also need to know from your A2 work how to differentiate sine. So differentiating sine just gives you cos, and the embedded part of that, when you're working out the chain rule, you're either going to do it the long way, which means you would let u, so we'll do it that over here, let u equal the embedded function, differentiate the embedded function, and then what you end up with here is dx dt would be dx du times du dx. So the du bits cancel and you end up with du dt, sorry. So the du's would cancel and you'd end up with dx dt. So dx du would be what you now have, which is 3 sine u. So x would be 3 sine u, and when you differentiate 3 sine u, dx du would be 3 cos u. So dx dt would be dx du, which is 3 cos u, times du dt, which is 2. So that's 6 cos u, and you know that u is 2t. So differentiating that, you get 6 cos 2t. In year 13, when you're going to be differentiating far more complicated things than a straightforward chain rule, all you have to remember is if you cover the embedded function, so you differentiate x with respect to your finger, so you would do dx d finger would be 3 cos finger, and then multiplied by the differential of what you covered up, which is 2. So you'd end up with 3 cos 2t times the differential of what you covered up, which is 2. You'd end up with the same thing. That would be the way that I would be expecting you, or a form of that quick method, to be able to deal with. So v is dx dt, so v is 6 cos 2t. There's no constant when you're differentiating, that's only when you're integrating. So then we have to go one more time to get the acceleration, which is what we were looking for, to put into Newton's second law. So the acceleration is dv dt. So we won't go through all that rigmarole again. So A is going to be, cover up the embedded, so it's going to be 6 times the differential of cos, differential cos is minus sine. So you're going to have 6 times minus, hang on, let me write that a bit better, otherwise we're going to end up with some confusion. So I've got 6 times minus sine of what I've covered up times the differential of what I've covered up. So differentiate 2t and you get 2. So you end up with minus 12 sine 2t. So that's the expression for the acceleration given time. And then if we go back to the question, we want the magnitude of f when t equals pi over 6. So most of the time in mechanics, when we're working with angles, we're working in degrees. However, when we start using calculus, whether we're differentiating or integrating, then the units will be given in terms of pi. So at time t is pi over 6, a will be minus 12 sine 2 pi by 6. So on our calculator we need to change from degrees into radians, which I'm guessing is going to be in setup, yeah. Angle unit, so number 2 and number 2 again for radians. So we want to work out what minus 12 sine fraction 2 pi on top, 6 underneath, close bracket, equals. If you SD that, yours will automatically go to that. Mine's set up different. So that gives me that the acceleration is minus 6 root 3. But I don't want the acceleration, I want the force. So now F equals ma. The mass is 0.2 kilos. So that would be 0.2 times minus 6 root 3. So times 0.2, so minus 6 root 3 over 5. Just check what they want. They want the magnitude of f, which means they're not interested in the direction, which is given by the symbol. So f is going to be how big the force is, which is 6 root 3 over 5 newtons. So with that question, it's AS level mechanics with a little bit of low level A2 pure maths, chain rule and trig functions.